Good day, students. My name is Imran Mohammed, technician in the Instrumentation and Robotics Research Lab. In the Robotics Research Lab, we have the Fanuc industrial robot. It has 6 axes of motion controlled by these servos, and it is also fitted with a pneumatic actuator. Alright, here we have the operation of the pneumatic gripper of the robot.
Listen. Hey.
Operates within a safety cage that disables a robot should anything enter the cage during operation. The robot is used to help students understand programming. It is also used in final year project.
Pre-engineering students, welcome again. What I'm going to do here, I'm going to display a simple manufacturing technology process. I'm going to go through the process from the beginning to the end. Let's say if we have to produce a decorative component like a steel pan. It's a miniature size pan, and it could be used as a decorative component. In the initial stage, what we have to do, we have to produce a drawing. Sketch goes with a drawing. After that, it has to go through a casting process. Casting meaning where you have to melt the material, ferrous or non-ferrous, pour it into a mold, and get the casting done. So once you produce the drawing, let's say if you want to produce this decorative component of a steel pan, you have to produce the drawings. We have to get it carved out of wax. So we melt the wax, produce a slab, and we carve it out. I don't have the carved aluminum here as yet. But what we have here, this is the carving done of a bird and a petal. And we have the steel pan style around here. This was carved manually out of wax. Okay, so as I say again, we have the petal, the bird, and the petal sitting on a steel pan here. What we did an aluminum one, we did a wax one out of steel pan. We mold it in the foundry, we cast it, there's a process called green sand mold. So we cast it and we get this end product. This is aluminum. Okay, the end product is the steel pan here now. Okay? Now, there is a male and female part of this. At the end of the day, we have to place a blank. This is a blank aluminum disc. We have to put it over here. There is a process that is called rubber pad forming, where we put the rubber like this here, mount it on a hydraulic press, and we compress. As we compress, the rubber will be forced into the profile of the solid steel pan. And in that way, we get the end product, which is this. So let me go it over again. We produce a sketch or a drawing, carve it out of wax, cast it out of aluminum, and prepare the blank. The blank will be produced on the lathe. This blank is produced by, it's difficult to hold this on the lathe. This blank is produced where you put two pieces of ply together and we rotate it on the lathe. Friction, this is a process that we call friction driving. So we produce the blank, put it on the die, put the rubber on it, compress it, and the rubber forms the profile of the die that we make. This is a simple manufacturing process that can be done to produce a decorative component. Thank you very much.
Good evening, my name is Hassan B. I am a senior laboratory assistant for the thermodynamics lab. Just going to run through some in the equipment position. So this here is the diesel engine test bed, which is for labs for first year students. So there's a diesel engine simulator. We run this engine and take readings from it. And then you can work out whatever calculations that you need to work out. That's just a brief summary of this machine. This other machine here, this is another diesel engine test bed, and this is used for testing like biofuel and other set of, well, biofuel. It starts off with diesel, and then we integrate the biofuel into the system and see how the engine runs, note any changes or efficiency in the engine. Right, so this is the Rankine cycler. It's a boiler used for one of the labs. The miniature boiler, we have everything contained in this. In this we have the turbine, the boiler itself, and the condenser. We use it to take various measurements such as DC amperage, DC volts, boiler temperature, boiler pressure, and a lot of other stuff. Right, so this is a larger scale version of our boiler. This is just a display so that students can see how the makeup of a boiler inside a boiler is. This is a fire engine tube boiler where the fire passes through the tubes here and heats up the water in the tank itself. So another display we have in the thermal lab is this turbine, you can come in closer and see how it's just for the students to see exactly what is contained and how a turbine does function. So you see the air intake comes from the front and it compresses and then it expands with the mixture gas. And that's just a brief over.
Alright, so here we have our 3D printer. In the CNC lab, we have 3D printers, right? Now one here, this is more of a production 3D printer. This is designed to work day and night. Here we have like a medium-sized one. Copy project. Also, we have a small mini one here, as you can see. So if you notice, each 3D printer has a small work envelope, as we call it. The work envelope is where it determines the size of the work that can be printed. So you can see this is a small one, right? This is probably around 6 inches by 6 inches you can print. Here we have a bigger one. You can look. So our work size could print around 12 inches by a height of probably 12 inches. All you have to do when you use the 3D printer, you design your work, you design your product in SolidWorks, and you can just come to the 3D printer using your flash drive and put it into the computer and print. So as you can see here, if you're looking at the glass case, these are some of the projects that was printed using the 3D printer. As you can see, we have a skull here. This is actual human skull. We got this CT scan from bedside that they use. These are like a turbine for a small miniature engine, a plane. No, it's plastic, so it wouldn't work. And you can see an engine block. These are turbines from turbo, bone pieces. Here, if you can look, this is what you call a Geneva wheel. So when you design your product with moving parts, when you 3D print, it will be able to move. Such as if you design a car with a steering, the steering will turn.
Hello, good day. My name is Lionel Hanuman Singh, and I'm the technician responsible for the Industrial Instrumentation Laboratory. In this laboratory, we deal with final year students with high pertinence to electronics on their projects. When they are through doing similar building and what have you, they will come here concerning their electronics and electrical part of the projects. Today I'm just going to demonstrate simple techniques that usually we will relate to the students first before getting into building the circuit. And one of the basic things that they must know and deal with properly is soldering. What is soldering? Soldering is, first thing first, this is a complete circuit board in which it consists of components. There's a task to be done by this board. If there's loose components or unsoldered or improper soldering, known as cold soldering, you will have issues with the breaking down of the board and what have you. So again, I am going to make a demonstration as to how it is that we the students and myself bring this job to total reality. Okay, so first thing first, you will mount the board on this special apparatus that we have made. Okay, again, what we are attempting to do is to remove a component. I'm just demonstrating this to you all, and this is how the student operate. Now let me introduce, this is Mr. Soldering Iron, in which he has a tip that is pretty hot. It could be in the vicinity of 100 watts actually, but it is set up there. That is a test control system that is adjustable by temperature. So I am, at present I have adjusted it to 22 watts. Okay, so you see that this can be far more heated than that. Alright, so before we start this, we would want to clean the soldering iron, Mr. Soldering Iron. I'm saying Mr. with this because please, if it touches you, it could have serious damage. Alright, so first we will clean the heated soldering iron. We will try with the solder. This is the solder there, that's the stack array of solder that we have there, in which they come in different gauges. Okay, and here I go. So I'm just going to try it, making sure that it has a shiny look. Anytime it's black, it's impure. It clearly shows that we have not implemented or taken out the majority of the impurities. Flux render that assistant. Alright, so let's assume I am going to remove, I would want to remove something big. Okay, so I'm removing, there is a capacitor here. I'm going to remove this. You can zoom in on it. Right, so this is the area here where the capacitor is to be removed. I will have to get a desolderer. Right, this is a desolderer. What it does is when the solder is in molten form, then this will, upon pressing it, there will be a suction on deploying it, and that will remove this solder. So here I go in trying to remove this. So I'll heat and remove, heat and remove. So I can comfortably now pull out the component. Alright, again, if you're looking into the board itself, we have no physical damage done to the etch itself, so it could be used back. I am attempting to put back in the component. Alright, so it's in, and right now I am trying to mechanically lock it in place. Good. Liquid flux has to be applied if you want a nice clean soldering. And finally, solder is applied. Now, for the first time, we are now going to actually make a bond. So in making this bond, what you will do is soldering iron on the work point, and then you put the solder. People have made the mistake and put the iron on the solder first. No. So you must bring a certain heat there, and then, alright, and now you have a permanent bond that has no form of cold soldering. Cold soldering will mean there is a loose connection. Alright, now I'm just going to demonstrate quickly how it is two wires is bonded. Here you would be able to see it properly. Alright, so two wires, again, don't forget the flux. Right, so we apply some flux on it. What the flux does is coat it and gives when you solder in, it actually pulls out the impurities, and the bond of the solder and heat will hold on the wire itself. without any impurities. So here we go, and boom, that's it. We have a proper soldering connection that cannot come apart. And by the way, this board what I'm holding here is actually from a past project, okay, in which a lot of soldering was supposed to be done. It's actually a MPhil student circuit done right, and one of the tables across there, that's the workstation. There are 8 workstations in this lab. All right, so this consists of transistors, which is driver transistors, and the opto isolator ICs. The skill behind soldering these things, you've got to be very good to solder it because of the pins, the smallness of the pins. And it was actually done by myself and the students. All right, we have access. The board is as such that you input from Arduino board. This amplifies the signal and drives motor through the output of it. So it's what you call an ESC, electronic speed control. Okay, ESC. This is something that was done here locally. This is how it is. All right, and that's it concerning the one little demonstration of this lab. There are so many other things that could be demonstrated concerning servo motors, DC motors, Arduinos, Megas drones, and so many other things. But I'm just here to demonstrate that because of the soldering technique that has to be implemented and practiced by the students, will produce great projects due to functionality of their circuit board. Thank you very much.
Good day everyone, and today we're going to look at the basic functions of a multimeter. First of all, we're going to start by checking the voltage in an AC supply. AC stands for alternating current. Example, the plugs that you have at home. So we're going to turn the meter onto the V here, and you see the wave? That wave stands for alternating current. So we're just going to check a normal 110 volts plug and see what we get. 108.78. So we're looking at this component here, which I took out from a lab equipment. So it is 2 resistors in parallel, and we are going to find out how much ohms it is. Right? So we switch our meter onto this symbol here, which is the symbol for ohms. Right? Resistance is measured in ohms. So we're going to check and see now. This number, okay, 200.7 ohms. Right? Right, so now we're going to look at connectivity. Right, so it simply means that we just want to make sure that here is connected, this part of the plug is connected to here, so when we plug in this, it will transfer through the wire and we will get the current and voltage through here. Right, so this here has 3 leads, here have 3 leads, so which makes the wire 3-core wire. Right, so now this should be connected to this should be connected to this, and here should be connected to here. Right, today we're just going to check and see to make sure that there's no break in the wire or anything disturbing the flow from here to reach here. Right, so we're just going to check this one here. So I put it here. Let's see if you can see here. Right, we hear the beep. So we know that it is there. If I put it here, we will not hear the beep because this lead is not connected to this lead here. This lead is connected to this lead. Now we're going to look at a AAA Energizer battery, right? Also known as a penlight battery. Now these are really 1.5 volts DC, but this is a used one. So we will see how much voltage we get from it. Alright, so I'm going to switch my meter here to the V with a dash on it, which means direct current. Right, so 1 lead here and 1 lead here. and we're getting 1.03 volts DC. As I said before, it's a used battery, and that's why we got that voltage. The rating for it is 1.5 volts DC. Good day, students, and welcome to the Pattern Laboratory. In this lab, we are equipped with various equipment and skilled technicians to fulfill the woodworking needs of students for undergraduate and postgraduate projects. Today, we will be looking at a spur gear. A gear is simply a toothed wheel that works with others to alter the relation between the speed of a driving mechanism and the speed of the driven parts. So the first step, we took our diagram and we stuck it onto the material. The material that we are using today is called PVC board. It is made from PVC resin, has the same process ability as wood, can be drilled, sawed, hammered, etc. This is what the material looks like. Right, so as you can see on our diagram, it is on a scale 1 to 1, meaning that it is the exact size that we want it on the sheet of paper. So all we have to do now is I will show you the different steps and processes of cutting it, right, to get the desired shape that we are looking for. Right, all the measurements are in inches. Right, they give you the angles, the amount of teeth, everything. So after this step here, I am going to draw lines coming down here, and we will be cutting it on the table saw. Right, the reason why we're cutting it on the table saw for is so that we could get pretty much close to the exact drawing, so that we wouldn't be wasting any material. Right, so this is the table saw that I mentioned earlier in the video. Right, so I'll just go down and show you how we could cut material on the table saw. Right, there's a couple different ways we could cut it. We could cut to get angles, 45 degrees, 60 degrees, we could get straight 90 degrees, it all depends. Right, so now this here is what we call the band. Right, so we use this, we take our measurements, 6 inches, and the material would be between parallel to the band and the saw for the 90 degrees cut. So as you can see, we will get a nice smooth cut here. Right. Another way of cutting with the table saw also, we use with the use of a mitre gauge. Right, we could cut angles with this. So I'll just give you a demo on. Right, so this is set at 45 degrees. So we could get a 45 degrees cut with the table saw also. Right, as you can see, I've drawn my lines and I've set it up onto the table saw here. So we are going to make the cut and start the process of making the gear. So. Right, so we cut up the material and we get it down to a smaller size. So now it's time to form the circle here. Right, so we end up with a few pieces of scrap board like this. a few pieces. So we have a recycle box where we throw it in so that students can use it later on for projects. Right, so this piece of equipment here is called the bandsaw. This equipment is used so that we could cut around the circle, we could cut all inside the gear tooth, all here, we could cut with the bandsaw. So let's go and show you an example of how we would be cutting this round part here with the bandsaw. Right? Always remember that using the table saw, the bandsaw, any piece of equipment, you must always have on your safety glasses and no loose jewelry on your hand or no long sleeve clothing or anything like that, because you don't want anything get caught up with the blade and or anything like that, right? So we're going to start now. Right, so we finished cut the piece into a circle. As you can see, we cut it to the line as close as possible, but we didn't want to go in further than that. So we will use this 24-inch sanding disc to sand it and get a perfect circle. Right, we're going to turn it on and we're going to start a sand. Okay, so we got the circle, and now we are going to work on the internal diameter here, right, which has a radius of 0.5 inches, which will have a diameter of 1 inch. But first we will use a center punch to punch a hole in the center so that we could get the drill bit of this. So we got the circle that we wanted. Now it's time to work on the internal diameter. First of all, we will be using a center punch to find the center of the circle. The radius is 0.5 inches, which is a 1 inch diameter. So we will be using a 1 inch drill bit to drill the hole to get the required size. So we have the piece screwed on to our board here, and now we are going to drill the internal diameter. Alright, so you see why the center punch is important for, because the drill bit will find the center here, and that is what we're going to use to drill, right? So go and pour on and drill. Right, so the final piece now is we are going to use back the bandsaw to cut out the tooth of the gears. So you can zoom in and look, and we're going to start a cut one. Right, so now we have the gear cut out. It's just a rough cut with the bandsaw, and now we'll use the sandpaper or emery and we will sand it out smooth. So what you are looking at is the finished product. Right, so from a square piece of board, we drilled and cut to form a spur gear.
Welcome to the Biosystem Lab and Field Machinery. So here at this lab we do a lot of equipment geared towards agriculture. So here we have a cocoa bean dryer, so basically you put the beans in it and you have a heating element that basically dries the bean. So it's used to dry the beans. Then you have here, you see here, this is what we call a hammer mill, and this one was particularly designed to actually crush the coconut husk and make it somewhat of a soil-like material to use for plants, or what we call mulch, right? And at the back, if you look carefully, this one here, right, is basically a fermenter for the cocoa bean. So you actually put the cocoa beans in there and you allow it to ferment over days, and you'll see where the liquid and stuff would drain out. And after this, you will take it to dry it.